I assume we were going to pick up from where we left off before?
Yeah.
Okay. Okay, so we talked about this problem number 1 last time a little bit. And the way we solved it... Excuse me?
Can we go back over it?
Sure. The way we solved it was, first of all, by graphing those points. And then we can also solve it without doing this. But the first time we should do it by graphing those points. So minus 2, 7. So there's the first point. Minus 2 comma 7. Second point is minus 1 comma 5. Third point, 0 comma 3. One, 1. And 2, 1. Now, if we draw a line connecting those dots, although that's not really necessary, but it helps a little bit to see what's going on. And goes all the way over to there. Is that a function? And why?
Yes.
It is a function because why?
Because the line doesn't cross over the same line twice.
Right. It passes what's called the vertical line test. In other words, if you try to draw a vertical line anywhere through that thing, no matter where you draw it, you only encounter the y value one time. As opposed to, if I had a function that was like this, that is not a function. In other words, it passes the vertical line test in places like that, but as soon as I get to there, I've got multiple y values for a given x. So that's the key, is if we have multiple y's for a given x, then it is not a function. So now let's see if we can solve these without graphing them. So the first one is the second one. Notice that the middle 2 points, 3 comma 5 and 0 comma 5, does not violate the function rule. And it looks like it might upon first glance. Can you see my cursor here?
Yeah.
In other words, 3 comma 5 and 0 comma 5, if we were to plot those, well, 3 comma 5 is right there and 0 comma 5 is right there. So when you connect those, that does not violate our rule. What we're looking for is multiple y's for a single x. In other words, if 3 produced a value of 5 in one spot and 3 produced a value of 6 in another spot, then for the given x, 3, there would be multiple y's, and that would not be a function. Now, there's some other considerations here, although I'm trying to figure out what they could possibly be. No, they're not. In other words, we don't need to graph this one. What we need for it not to be a function is if there are two x's that both have a different y, and we know that can't happen because there aren't two different x's. I mean, there aren't two x's that are the same, is what I meant. In other words, you have a -7, a +3, a 0, a -2, a +6, a -6, and a 4, assuming that this is a +6. It looks like they left the parentheses off. But assuming that that is a +6, then we can't have two y's for the same x because we don't even have two different x's. So this has to be a function also. Let's look at number 3. Aha. Notice that number 3 has one data point that is 2, -1, and it has another data point that is 2, 7. Well, if I was graphing those, here's what they would graph like. 2, -1, so that point is right there. 2, -1. And this other point, 2, 7, is right here, directly above it. So no matter what the rest of the points are on this function, it's going to fail the vertical line test just with those 2 points alone. As I'm passing a vertical line through this function, I get 2 different values for y for a single value for x. And that's all I need to dispute that that's a function. And that's all you need for an answer, is because of that data point and that data point, it is not a function because you have 2 different values of y for a single value of x. Okay. And I assume that these instructions here were meant for 4, 5, 6, 7, 8, and 9 also. Correct? Which of the relations below are functions? Explain how you know. About number 4, is that a function? Marina, you still there? Marina?
Can you hear me?
Now I can. Quite a while I couldn't hear you.
Well, I said, I think 4 and 5 are functions except for number 6.
Good. 4 has to be a function because there are no multiple x's. Same with 5. There's no values in the x column that duplicate. 6, it duplicates right there. Those first 2 alone make it not a function, plus these 2 here make it not a function. Okay, how about 7?
It is a function.
Yeah, it looks to me like it is. How about 8?
Yes.
About 9?
No.
It not only fails the vertical line test, but at a whole bunch of values for x, there's 2 different values for y. In other words, when x is -2, y is +2, but y is also -2. down here. So how about number 10, circle?
No.
11?
Yes.
12?
Yes.
Toward the homework always this easy.
Yeah.
Is that all you got for me?
I guess. I thought it was going to take longer.
Yeah, I kind of did too. I didn't really look at this very much. Want to practice your math skills for a little bit?
Yeah.
Let me make up problems and you answer them.
Alright.
As fast as you can.
-2. Hello?
Yeah, no, that's correct. I'll say something when I'll say something regardless. Yes, -2 is correct. Yeah. And -7 minus 5?
-12.
Good. Multiplication?
1/6.
One-sixth was correct. How about this one?
1/2.
Okay, how do we divide fractions?
Multiply by the denominator.
Well, not by the denominator, by the reciprocal of the denominator. So I got to flip the denominator over like that, and then it's the same as dividing. So this becomes 3/4. Because 1/2 times 3/2 is multiply the numerators, multiply the denominators. Okay? Not done, hold on.
Oh wait, Mr. Wait, I forgot your name. But for the blue worksheet,
Uh-huh.
oh wait, never mind.
You sent, yeah, I think you sent me 2 the last time we met, and we went over the first one, and then the second one we went over today.
Oh, okay.
Okay? I'm just going to throw out random stuff here.
Nine.
Solve for x.
X equals 9.
Plus or minus 9.
Plus or minus 9.
Notice the difference. This is definitely plus or minus 9, and that is 9. Because when you write the radical sign, it's presumed that we're talking about the plus result. Okay?
Alright.
Adding and subtracting fractions is by far more difficult than multiplying them. Multiplying them is a piece of cake. Multiply numerators, multiply denominators. Adding and subtracting is much harder. What do I have to do here?
Find a equal
A least common denominator. By common, it means that the denominator can be divided by both of these numbers evenly. So what would the least common denominator be here?
12.
Okay, so now what does the problem become?
1 over 12 minus 1 over 12.
No, in other words, we need different numerators. In other words, what fraction of twelfths is equal to 1/3? What did I have to do to the 3 to turn it into a 12?
Multiply by 4, so it would be 4 twelfths.
What did I have to do to the 4 to turn it into a 12?
Multiply by 3, so it would be 3 twelfths.
So what's the answer?
1/12.
Very good. Okay, let me think of some other algebra stuff. Solve this for x.
It would be x over 4 equals 2 over 3.
No?
Negative 2 over 3.
No? We can do a couple things. We can, usually, your first goal is to get x isolated on one side all by itself. That's your goal when you're solving these equations. So usually the first step is to move any constants to the other side. In other words, we know we want the constants on the right side, the terms with the variables in them on the left side. So let's subtract 1/3 from both sides. So x over 4 equals, what is 2 minus 1/3?
1 2/3.
Good. Which I can write as 1 2/3, or I can write it as 5/3. I'm going to write it as 5/3 because it makes solving this equation a little easier. Now what?
And then multiply both sides by 4 over 1.
So what's the answer here? When I multiply the right side by 4, what do I get?
25 over 3.
Well, almost. 20 over 3.
Oh, sorry, 20 over 3.
That's okay. That's okay. You're doing good so far. Real good. So I could either leave this as 20 over 3, but if I chose to turn that into a proper fraction, what is it? This is an improper fraction, meaning it's greater than 1. So if I want to turn this into a whole number, kind of like you turned 2 minus 1/3 into 1 2/3, that's the proper fraction, and I turned it into an improper fraction, 5/3. So turn this 20 over 3 into a proper fraction.
It'd be 6 2/3.
Good. Okay. Next line.
So you do minus 6, so it would be the square root of x minus 2 equals 4.
Next line.
Add the square root of 2.
Do what?
2.
Not yet. Not yet, because it's still inside that radical sign. So we can't remove it without doing something first.
Square root the 4.
Square both sides. Not square root the 4. That's kind of going in the wrong direction. We want to square the 4. In other words, we could square root the 4, but then we would have the square root of x minus 2 equals 2. We want to get rid of the radical sign. That's another thing about when you're solving algebraic equations and you have a radical sign, your goal is to get rid of the radical sign. And how do we do it? By squaring both sides. So what's the next line? What do you get when you square the left side? What do you get?
X minus 2.
When you square the right side, what do you get?
16.
Now what? Now the final line.
Wait, can you hear me?
Yeah. What's the final line of our equation?
18.
Good.
X equals 18.
And notice what happened if I would have taken the 2 over before getting rid of the radical. I would have had square root of x equals 6. Then when I squared both sides, I would have had x equal 36, the wrong answer. So it's very important the order of these operations that you do. Okay, now let's look at this function right here, the one we started with. What is its domain?
All real numbers.
What happens if I let x be 0? What am I going to end up doing?
Find the square root of negative 2.
Which you can't do. You can't take the square root of negative numbers. So that restricts x. So the way we're going to solve this to figure out what x can be is we're going to say, well, we know that whatever is under the radical has to be greater than or equal to 0. No matter what's under that radical, that's what we're going to say. So what's the answer for x? Solve this inequality.
X is greater than or equal to 2.
Exactly. And that's its domain. X has to be greater than or equal to 2. Anything less than that, and you will be taking the square root of a negative number, which violates all kinds of math.
Okay.
Well, this is actually good, I think. I think that this is as helpful as anything we do. Not that we need to continue doing it for an hour. I mean, you're doing pretty good on this reviewing. But I think this kind of drilling is real important for you. I suspect that any problems you're missing in your algebra class, tell me if I'm wrong, but I suspect that at least half of them are due to math errors and not understanding what you're supposed to do.
Probably about half of them, yeah.
That's what I would guess. So if you can fix that, I'm assuming you have to take your test without calculators, right?
Sometimes. It depends on the problem.
Yeah, both types? Okay. But certainly there's lots of areas where you're going to need to be able to do math. And that's something you can work on your own. I mean, I'm happy to work with you on it when we have time, like tonight, where we don't have other material to go over. And I think it's real helpful to do that. So what's this?
2.
Good. Okay. You're doing all these without a calculator, I presume?
Yeah.
Although that'd be actually hard to do on a calculator. I mean, you'd have to be real careful putting that into a calculator. A lot of calculators have different signs for subtraction as opposed to the negative sign. The modern graphing calculators do. And there's a different key for subtraction as opposed to a negative sign. All right. Well, why don't we just do a half-hour session tonight? And let's see. Unless you have other stuff that you'd like to go over, I'm certainly willing to do a full hour, but we don't need to. I'm seeing you again Wednesday night at 7.
Oh, yeah.
And again Thursday at 4. So we've got lots of sessions scheduled this week. So why don't you try to make sure you bring enough material for those 2 days.
Wait, what day is that for?
Well, I got you at Wednesday, May 8th at 7. And also Thursday, May 9th at 4.
Oh, yeah, okay.
Now, just a second. There's a note on the Wednesday one. Maybe prepare for test. I'll be out of town. I gave you my husband's phone number. So I guess I have to contact him. Do you know that phone number right offhand?
Yeah, that's my dad's number.
What is it? She didn't put it on the... Oh, it's right here, 748-7539?
Yeah.
Okay. So that's the one that I should text the meeting ID number to?
Yes.
Okay. I will talk to you Wednesday night.
Okay, thank you.
All right, Marina. Have a good one. Bye-bye.
You too, bye.